In a world where storage prices are hitting the stratosphere faster than you can say, what the heck is up with that? Us Raspberry Pi fans are actually incredibly lucky. While everyone else is selling a kidney for another monthly cloud subscription or an overpriced NAS unit, we are going to build a full-fledged home server powerhouse right here, right now. And we're doing it using our tiny microcomputer and a couple of random external USB drives you probably have gathering dust in a closet from back when a terabyte cost less than a movie ticket. Today, we aren't just going to jank this together with duct tape and prayers. No way. We are building a high-performance monster. We're going to merge two separate drives into a single unified array and learn a simple trick to squeeze out almost double the speed. Along the way, we'll appreciate the sheer magic of this little board doing things it honestly has no business doing. And as a dessert later on, I'll tell you how this dirt cheap Raspberry Pi managed to conquer a tiny nation of millionaires where they use it in ways that will make your jaw drop. Spoiler alert, it's not about running a smart greenhouse on a balcony. Let's go. All right, on the operating table today we have a Raspberry Pi 5, decked out in the glorious Pyronman 5 case. I already did a review on this piece of aluminum art. There's a ton of unexpected stuff in there, so definitely check that out. But only after you finish watching this video, deal? To the Pi, we're attaching two external hard drives. I've got a trusty 500GB Western Digital and some ancient nameless 1TB SATA drive sitting in a cheap Chinese USB adapter. A classic setup. To keep this server masterpiece from vibrating right off the desk, I 3D printed a custom exoskeleton, two drive cages, and a sweet stand for the Pi itself. Let's assemble all this hardware goodness and jump into the software magic. First things first, we need an absolutely squeaky clean SD card with a fresh Raspberry Pi OS image. But listen closely, ladies and gentlemen. Make two SD cards with the system right now. Why? Oh, believe me, this little backup hack is going to save your sanity a bit later. Spoiler, I messed up big time during this build. The imaging process is basic, so we won't dwell on it. I flashed the version with the graphical desktop just for pretty visuals in the video, but honestly, the minimal version with just the naked command line is way more than enough. Real Jedi work in the terminal anyway. Let's jump into the system. Our entire plan breaks down into 10 logical steps. First, install the Gentleman's Kit utilities for the Pyroman case, the volume manager, and monitoring software. This all installs via the package manager with a snap of your fingers. Reboot. And voila. Our Raspberry Pi is already glowing, spinning its fans and showing stats on its fancy little screen. Beautiful. Now, let's descend into the terminal dungeon. We need to brutally and mercilessly wipe those external drives to avoid conflicts in the future. Pay attention here, I'm using SDA and SDB since I only have two drives total. If you have a whole Christmas garland of drives connected to your Pi, adapt the commands to your specific setup. The drives are clean. Let's create the volume manager structures, and right here is where the real techno sorcery begins. We need to find out the exact number of physical extents on our external drives. This step is critical because we are building a RAID 0 striped volume with parallel writing. What does that mean for the average person? Data will be written to both drives simultaneously. Ideally, speed shoots into space and increases almost twofold. Yes, I know, my drives have different capacities and block sizes, so we won't get maximum synthetic benchmark speeds, but it's still vastly faster than kicking a single SAD drive over USB. We take the size of the smaller hard drive and create our logical volume based on that limit. The volume is ready. We slap a default X4 file system on top of it. For our goals, that's plenty. We create a mount point and hook our new logical volume up to it. Now we need to find the UUID of our disk so it mounts automatically at boot via the fstab file. And right here, folks, we arrive at the exact reason I forced you to make that second SD card. Watch my hands closely. When copying the line from the manual, I made a rookie mistake. I missed the UUID equals part and just pasted the raw ID string. The result? The OS said, I don't understand you, couldn't mount the file system, and flat out refused to boot. Finita la commedia. That's exactly when I whipped out the spare card, booted from it, hacked into the broken system and fixed my clumsy typing in fstab. So please, learn from my mistakes. The system is alive. It is time for Docker. The installation process here is automated into a one-button masterpiece. Just download the script and run it. Bam! Next, throw your user into the Docker group so you don't have to type sudo before every single command and hit new grop Docker. Docker is in place, but we need to move its standard directories onto our freshly built high-speed RAID array. Done. And while we're at it, let's immediately define repository mirrors. Because if Docker's main site starts acting up again tomorrow, blocking IP addresses and asking us to prove we aren't robots, we'll be fully armed. It's a bulletproof setup. Restart Docker. The final boss, installing the containers themselves. Technically, for a private cloud, we only need the Nextcloud stack. But so you don't fall asleep looking at a black terminal screen, I'll throw Portainer on top. You don't strictly need it for the cloud to work, but with it, seeing the whole internal kitchen via a browser is much clearer. Portainer is installed. We prepare the landing zone on our RAID array for the cloud data, create a directory on our Raspberry Pi server, and set the permissions. Now, hop into the Portainer interface, create a new stack, and just copy-paste our config right in there. In a nutshell, we are right now simultaneously spinning up a MariaDB database server and the Nextcloud server itself. Eyes on the screen here. You need to specify two different passwords, one for the database itself and a second one for the Nextcloud user, and you feed that exact same user password into the configuration section of Nextcloud itself. That's it. Hit the deploy button and go make some tea while Portainer does all the dirty work for us. And while Portainer is huffing and puffing, unpacking those containers, you have the perfect window of opportunity to smash that like button and subscribe to the channel. Did you do it? You absolute legends. In the meantime, I'm going to fire up a console utility called Glances. Honestly, the cloud doesn't need it to run at all. But I want to show you some pure, unfiltered techno sorcery in real time. Look at the disk I/O section on the left. See devices SDA and SDB. Those are our physical drives individually, but device DM-0 is our virtual volume, our software RAID, currently orchestrating the data flow live. Meanwhile, our stack has successfully deployed. Let's dive into the Nextcloud web interface, which we cleverly hooked up to port 80 Punch in the login and password, and the smart system will handle the rest automatically. We sit back, wait for Nextcloud to settle into the server, and we can already see on the Glances interface that the graphs are starting to climb. Writing has started simultaneously on both disks, and these are just its own internal service files so far. Installation complete, the cloud interface is alive. Let's feed it a couple of photos from our imaginary luxury vacation in Monaco. The photos are flying up, and again in the monitoring we see the load being smeared evenly across both hard drives. Yeah guys, look, this isn't some expensive PC IE 5.0 NVMe setup, but for a budget Frankenstein build made of old USB drives, the speed is honestly nothing to sneeze at. But photos are child's play. Let's move on to heavy artillery. We're setting up a Windows desktop to sync with our little Pi. No jumping through hoops here. I already downloaded the client from the official Nextcloud site. Launch it, install in 2 clicks, hammer in the IP address of our server. It throws us to the browser, we authorize it, give it the thumbs up, choose a folder to sync on the computer, and boom, a few seconds later, our vacation photos are already sitting on the desktop. And now for the real crash test. Let's dump some heavy video files from Monaco into the sync folder. The disks immediately start crunching furiously and the Glances graphs shoot through the roof. And here you might logically ask, listen, why all the Monaco references? What's with the fixation on the city of millionaires? And I'll tell you why. Because right now you are looking at these shots of luxury and you don't even suspect that in the centre of all this elite infrastructure beats the silicon heart of our beloved Raspberry Pi. Take the legendary Oceanographic Museum of Monaco, which is flashing on screen right now. It's not just an aquarium with fish. It's a world-class research centre. They recently launched a huge polar mission exhibition about the Arctic. You walk into the hall and there are 34 video projectors and a bunch of LiDAR sensors tracking your every move, so the ice in the projection cracks realistically right under your feet. And do you know what the algorithms processing those LiDARs are running on? On nodes with Raspberry Pi architecture. Furthermore, local scientists use the Pi for serious environmental research. They build dirt cheap setups based on Raspberry Pi and Python to monitor water quality, temperature and pH in tanks with live jellyfish. A professional industrial logger for tasks like that costs about €5,000, but the guys from the Monaco Scientific Centre assemble an analog for $150 that also sends data via Wi-Fi straight to the browser. A tiny budget computer in the very heart of absolute luxury and advanced science. If that's not mind-blowing, I don't know what is. All right, snapping back to reality and down to earth to our NAS. Let's open our heavy video files right through the Pi's web interface to make sure everything is there, everything loaded, and it works without any stuttering. The system is a beast. And one final touch. Since our server is finely tuned and running like a Swiss watch, let's switch the Raspberry Pi back to booting into the naked command line. We don't need the graphical interface anymore, and freeing up an extra couple hundred megabytes of RAM definitely won't hurt the server. And oh yeah, a little cherry on top. If you want to casually dump videos from your iPhone or Android onto your home cloud straight from the beach, like a boss, you'll need to set up a VPN using Tailscale. A detailed guide on that particular magic is already on the channel. Go ahead and click the card in the corner of the screen. And if you need my text-based runbook with all the copy-paste commands, or if you still have questions, drop them in the comments. I read everything. Subscribe to the channel so you don't miss the next insane adventures of our little Pi. Stock up on hard drives before their prices shoot to the moon again, and I'll see you soon. Peace out, guys.